Hi guys, welcome to this supplementary video for option A, databases. In this video, I want to cover some topics that I unfortunately wasn't able to cover in the first video, which covered almost the entirety of option A. In my defense, I made that video in about a weekend, including editing and uploading to YouTube and sorting everything out on YouTube. So I didn't really have a lot of time to spend on it, and unfortunately that means some things were left out. Anyways, in this video, we're going to be covering writing SQL queries, derived fields, and joins. And all the content on this slideshow will be added to both the study guide and the slides for those who've actually purchased the option A slides and study guide. So if you did purchase those, you can go back to that link that you received by email, and you'll automatically be able to download the updated materials. Anyways, let's get started. One thing I do want to point out before we get started is on the actual syllabus for option A, it says students will not be expected to be able to write queries in SQL, which is actually what I assumed when I made the first video. But the reality is that there are quite a few questions where it's a lot easier just to write SQL than it is to try to explain it any other way. And in fact, I don't really see how you could effectively answer those questions without actually being able to write SQL queries. And yeah, the curriculum is inconsistent because here you're supposed to be able to use Boolean operators to create parameter queries. Then in the next section, it says that you don't need to be able to write them. So I don't know, it's not clear, but whatever I cover in this video is going to be on the exam, and I'll show you some IB questions to go along with the material. So the first thing we're going to cover is select statements in SQL. Now SQL is essentially a language we can use in order to get data from a database or manipulate data in that database in some way. Select statements are probably the most common types of statements we'll use, as they're used to extract information from a given table in a database. So this is the basic structure of a select statement. We have the select keyword, we have some fields that we want to get data from, and then we have the table. After the from keyword, we have the table that we're actually going to be getting our data from. So select and from are key aspects when extracting data using SQL. Now let me just show you an example here. So what we're going to do in these next few examples is get all the values in a specific field, like product name or price, from a table, using these two statements. So if we look at the first statement, select product name from products. Right here, we're always going to have a name of a field. So in this case, we're talking about the field product name. So that's this field right here in the products table. This entire thing is the products table. So when we execute this query, this is what our output is going to be. We're literally going to have everything in the product name field, which is just Chase, Chang, aniseed syrup, Chef Anton's Cajun seasoning, and Chef Anton's gumbo mix. So this would be our output. We want everything in the product name field. Now we can work with more than one field at a time. So for example, right here, we're working with both the product name and price field. So we want to get everything in the product name and price field from the table products. So this is what our output ends up being. We get everything from the product name and price fields. Notice these are all in the same order as they're displayed in the table, and they're all matching. So we have Chase, and that has a price of 18, Chang, and a price of 19, and so forth. So they're going to be matching pieces of data between the fields. Now, next, what we can do is go beyond just getting data in fields, and we can get data according to certain criteria. In these particular queries, we see the where keyword. So the structure is essentially the same as in our previous set of queries. For example, in this first query right here, we have the field we're going to be working with, and we have the table. We also have a where query, and we also have a where keyword, and then we have certain criteria for the rows that we want to output, which is that the price is greater than 20, for example. And we can also have more complex criteria like this one right here. And what these basically make use of are Boolean operators like we've seen in programming. There are some slight differences, like for example, this one right here, which just means not equal to. But by and large, if you understand how if statements work and Boolean expressions work in programming, then this should be a breeze for you. Now let's take a closer look at these examples and how they work. So right here we have select product name from products where price is greater than 20. This means that we just want to print out items in the product name field. And we're going to print out product names or items in the product name field whose price is greater than 20. So if you look right here at price, this is going to match up to our field price. We have two items. Let's see, we have two items that are greater than 20, this one and this one right here. So for these, we're going to be printing out the corresponding product names because we have product name right here. And as a result, this is our output for this particular query. Now next, in this query, we have a star right here. Now the star means we're going to print out every single field in the table for whatever rows are specified. So we're going to print out every table or every row from the table of products where the supplier ID is not equal to 1. That's what this weird little symbol means right here. Now supplier ID is another field in our table right here. So we're going to look for all of the supplier IDs that are not equal to 1. That's going to be right here and right here. So we're going to print out all the fields for these rows. That means everything on this row and everything on this row, like we see right down here. I guess that kind of messed up the order in my example. Like I put the price here and then product name right here and product ID. I kind of moved it around. This should be right here. But regardless, that's more or less what our output would be. Okay, now let's take a look at this example, which is probably the most complex. So the first thing we need to point out is that we're actually going to be printing out the values for two fields, which are product ID and price. So we're going to be printing out two things for matching rows. Then we've got a complicated set of criteria right here. So we're also using some more complex Boolean operators. I guess not more complex, but just operators we haven't seen before. So we need to look for rows where first the price is greater than or equal to 18 and less than 22. So greater than or equal to 18 means right here. That's meets both criteria, and this meets both criteria as well. So we have three candidates, but then we have another criteria to narrow it down. So unit like boxes with percentage signs. So I'm going to go ahead and write this down right here so you can really break it down. So unit like boxes. So we use like in order to look for a string in a given field. So that means we're looking for the boxes string right here in our field unit right here. Percentage sign simply means that we're looking for any rows where we have boxes and there are 0 or more characters around that string. So there's stuff around the string boxes, but it's somewhere in that particular field. So we're going to have two matches. Actually, I'll write this. So we'll have two matches. We have one right here because we have boxes. And then we have another right here because we have boxes here as well. Now, the last one is at the end, boxes at the end, but the percentage sign means there can be 0 or more characters on either side of boxes. Now on the IB exam, for some reason, instead of percentage signs, they use stars. I really do not understand why they do that because I've never seen it anywhere online or in any material at all from other websites. But the IB does that to essentially mean the same thing. So that means that we have two matching rows, which are this one right here and this one right here. And so we're going to have the product ID 5 with the price 21.35. And I also forgot to add that we're going to have the product ID 1 with the price 18. Now these would actually be in reverse order, so product ID 1 should be first and 5 should be after that, but I'm not going to split hairs here. When I was making this, I actually just made a mistake. I forgot to consider the fact that it's greater than or equals to, not just greater than. Anyways, that's the output we would get. So that being said, what I want to do is I want to take a closer look at this like keyword, because this is something that actually comes up on the IB exam. So we're going to look at two examples of comparing strings using both the typical Boolean operator and like itself. Now, right here, we have select product name from products where unit equals 36 boxes. That means we're going to look in the field unit for some string, for some value that is literally just 36 boxes and nothing else. And this is the only entry where unit is just 36 boxes and is exactly that. So we would just print out the product name for that. Here, if we use this operator, we require an exact match, which is not true when we use the like operator. In the like operator, depending on how we form it, we can have whatever string we specify. Well, we're really just looking whether the string that we specify exists amidst other strings. So we're just looking to see whether boxes is somewhere in a given entry for a field. So select product name from products where unit like boxes. So if you look at unit, we have boxes here and we have boxes right here. So we can go ahead and print out the product name for both of those rows. It's kind of why in some ways like is more useful, because you don't have to be searching for a very specific term. Just anywhere there is some string, you can find a matching record. And again, on the IB exam, these are stars, not percentage signs, for God knows what reason. Now, the next type of SQL query I want to look at is going to be the sum query. Now, to be honest, I haven't seen this in the exam. Someone did ask me a question about it. So just to kind of cover all the bases, I am just going to go over how this works. So sums are essentially used for adding up values across the table. So here are two examples of how we would use the sum operator, or really the sum function. So sum price from products where category ID equals 2. So let's go to the category ID field, and we have 2 right here. So that means we would just add up all of these values, and that's what our output would be. Our output would literally be the sum of these, which is like, let's see, 22, like I guess 33, 35. And here if we do sum price from products where price is less than or equal to 22. So we're gonna have this value, this value, this value, and this value. And we're gonna add up the prices for all those matching rows. So we'd have 18 plus 19 plus 10 plus 21.35. And actually I guess 22 matches as well because it's less than or equal to. So essentially we'd be adding all the values up, and the sum of all this sum right here would be our answer. Again, I haven't personally seen that in the IB exam, but someone did ask me a question about it. So I just wanted to cover my bases as far as this goes. So this is our first IB question that makes use of the material that we just went over. So right here it says, describe the steps in a query that will output the names of all students who earned the maximum mark on exam 2. Now, I haven't actually included the full question, but just so you know, in this particular question, the maximum mark was 100. And right here, we have another question about candidates who passed. And basically, to pass your exams, you had to get greater than a 30 on all exams, and you had to have a cumulative total of greater than 150. So greater than 30 on all exams, and then you had to have a greater than 150 cumulative total. And this isn't even the whole table, but this was just an example. So the names of all students who earned the maximum mark on exam 2. So what we actually want to be able to print out for this one is student name. Student name for all students who earned the maximum mark. That means greater than or equal to 100 on exam 2. So what we're going to do first, we're going to write select student name from, and the name of this table is class table, and then we're going to have where. Our criteria is going to be exam 2 is greater than or equal to, or I guess if it's the maximum, we don't need greater than or equal to, but just equal to 100. And that's pretty much it. Let's go ahead and check our work, and it looks like we got it right here. So 1 point for selecting the correct field right here, 1 point for a correct comparison right here. It says accept logically equivalent answers, but I don't even really know what that would be. I feel like you just really need to write SQL. Now next, the student ID of all candidates who passed. So remember, all candidates who passed would have received greater than 30 on all exams and greater than 150 cumulatively. So we're going to have a slightly longer query. And also this time we're printing out student IDs, not student names. So I'm going to write this smaller. We're going to say select student ID where. So we're just going to say, well, basically each individual exam has to be greater than 30. I think it was actually greater than or equals to, not greater than 30. My bad. Total is greater than or equal to 150. So let's go ahead and check our work. And okay, so right here, greater than or equal to 30, greater than or equal to 30, greater than or equal to 30, and total is greater than or equal to 150. So yeah, actually right here, I wrote the equal sign first, but our operator is really going to be the inequality and then the equal sign. So just keep that in mind right there. Sometimes I do mess that up. So anyways, that's our first IB question. Let's move on to another question. Okay, so right here, we have a table loans. With reference to the table loans, state the output of the following query. So we're going to select this loan ID, customer ID, amount, and type. And we're going to be printing all of those out. So we could actually replace this with a star, but we're not running this query. They are, so whatever. Where loans.amount is greater than 600,000 and loans.type equals home. So let's start with loans.amount is greater than 600,000. So these are our amounts right here. This is our amount field. And let's see, greater than 600,000 is going to be this one right here, and this one right here. Okay, and loans.type equals home. We'll just give that a different color. Loans.type equals home. So that's going to be, okay, this one right here and this one right here, for example. Or loans.type equals venture. Okay, so loans.type equals home or loans.type equals venture. So that includes this and this right here. So basically our output would, let's see, loans ID. Okay, so basically our output would just be, I'm not gonna like rewrite it, but it would just be like these 3 rows, every single field in these 3 rows, right? So it's just gonna be all of this right here. And I don't actually have the mark scheme for this one for some reason, but this was basically the correct answer. Now to look at our next question, we have a slightly more complicated SQL query. It says identify the steps to create a query to find the vineyards and names of fruity wines where quantity in stock is between 25 and 35 bottles. So we're going to be checking the stock quantity. Okay, so I'm going to write down what matches the criteria in blue. Or actually, I'll write it down in red. So we're going to be, our one criteria is going to be stock quantity. And the next criteria is actually going to be in the description. So fruity wines. So we're going to be looking in the description for fruity. And let's see where the quantity in stock is between 25 and 35 bottles. We want to print out the vineyards and names. So, okay, we want to print out the vineyard, and it's going to be in blue, and names. So we're going to do select name of wine, comma, vineyard, from, I don't remember what the name of this table is, but we'll just call it wines. We'll call this table wines, where. Okay, so we're going to say first description, like fruity, because we've got fruity right here. And we're going to use our stars. We're going to say star fruity. That star just represents the percentage signs we saw in our earlier explanation of like. And then I'm going to write it down here, and, because that all has to be true. And stock quantity is, let's say, greater than 25. It says between, so it's probably greater than 25. And stock quantity is less than 25, or less than 35, my bad. Okay, so that's the entire query. Let's go ahead and check our answer. Okay, so I think we got it right. So there's some example answers right here. It says stock quantity is greater than or equal to 25, and stock quantity is less than or equal to 35. And, okay, description like fruity. So right here it says allow greater than 25 and less than 35, so we're still in the clear. So I guess maybe this is an example of like where you wouldn't need to write a SQL query. So I guess that's kind of weird, but I guess that is what an option is that wouldn't be a SQL query. But it almost looks exactly like a SQL query anyways, so this might be the easier way to go. But yeah, the name of the table is actually wine, not wines. But other than that, I think we did a pretty good job. And here you can actually notice the stars right here, where really a percentage sign should have been there, but I guess the IB has their own version of computer science. Okay, now let's move on to our next topic, which is going to be derived fields. Now, derived fields, this is another concept that I didn't cover in my previous video, and this refers to a field that we are creating that doesn't actually exist as part of the table. It's sort of just a separate virtual field, if you will, and the main reason we would create a derived field, like an artificial field with some information, is mainly to display data more cleanly, in a more, I guess, easy to understand way, and also to be able to more efficiently get and process data and then display it in a single list. So for example, if we were to create a derived field from this table, the class table, we might use a query like this with the as keyword. So it says select total divided by 3 as average from students. So that means we would essentially be creating another field that we could display, and it would look something like this. And every single record would be a matching total divided by 3. So it might be like 33, sorry, not 33, and then whatever 196 is divided by 3, etc. until the end. And this is just going to be another field that we can output and that we can show. So select total as average from students. Basically, we're taking data from, I guess this would have to be class table. It should actually be class table. So we're taking data from the class table, and we're taking it specifically from our totals field. Although we could take data from multiple fields and combine it in a certain way. We are processing that data by dividing it by 3, and then we are displaying some new field that we've created. And the name of that new field is specified when we use the as keyword, which is in blue. Anyways, that is a derived field. And because derived field is technically not part of the table, any sort of normalization doesn't affect it. It's mainly there for cosmetic or performance-related reasons. That being said, let's take a look at a field involving derived questions, or derived fields, from the IB exam. So we saw this table earlier involving wine. Here we have another question that's associated with that wine table. It says identify the steps to create a non-persistent derived field called total price, which would hold the total value of wine stored for each record. So this basically means that we need to create a SQL query in order to display the total value of wine stored for each record. So let's go ahead and take a look at this table right here. So we have a unit price for each unit of wine, and then we have the number or the quantity of that particular type of wine that's been sold. So basically for each record, if we wanted to find the total price, then we would have to multiply whatever is in the unit price by whatever is in the stock quantity. So if we wanted to write a query to do that, we would just say select, and we would say unit price times stock quantity. So it would look something like this: unit price times stock quantity. Actually, how is that written? Stock QTY. And then we're going to use that as keyword. I'll put that in red, as. And we're going to be storing that as total price, or total, not total total price, from, and what's the name of the table? I think the name of the table is wine. And this is how we would create our derived field. Again, this technically, this isn't part of the table, it's just another field that we're creating that shows the data from the table that's been processed in some way, allows us to display it in an efficient and easy to understand way. And our next question is outline why the inclusion of a derived field will not affect the normalization of a database. The main answer is that this derived field is technically not a part of the database, so there's no reason why normalization should affect it. But let's go see what the mark scheme says. So our first answer is correct. Our answer right here is a derived field. So our answer to this question as to why it will not affect the normalization. A derived field is created but does not exist in the table, and it's something that's temporary. It's also not affected by duplication or redundancy, and there's no new dependencies that are created. So because this derived field is technically not part of the table, there's no dependencies, there's no relationships that are created. There's no reason why normalization would make any sort of, or be changed in any way as a result of a derived field. So to get 2 points, you'd have to have 2 particular reasons from this sort of like smorgasbord of reasons here. Okay, so now let's take a look at another concept that still involves SQL queries, but is slightly different from our previous concepts in the sense that now we'll be working with 2 tables instead of just 1 table. So joins are used to get matching information from 2 tables and store the result in a 3rd derived table. Now, we're going to be referring to this whole concept or process as a join, but the reality is when you look up this concept online, it's probably going to be referred to as an inner join, and indeed that's the SQL keyword that we're going to be using. Anyways, to illustrate how this actually works, let's say we have 2 tables. We have a customers table and we have an orders table. In each table, we have a field called customer ID, and, well, okay, in customers table, we have a field called customer ID, and orders table, we have a field called customer. But these really both hold the same information, which are IDs of specific customers. So using a join, what we could do is we could find the records the records in both tables that share a customer ID. So for example, in this table, we can get this record, and in this table, we can get this record, and we can put the information together because both records share a customer ID of 3. Similarly, we could get this record from this table and this record from this table and combine the information into one table because both records have a customer ID of 5. We can basically check that these match up to each other and then extract data accordingly. Now let's see how that looks in terms of actual SQL. So this is what our SQL query would look like. So right here, if we look at our resultant table, we have a customer ID, a first name, and an amount. So based on customer IDs, we were getting a first name and amount. And the idea is that we're actually getting the first name and amount for customers that exist in both the customer's ID and the orders, or both the customers table and the orders table. So we're just getting information for, basically what exists in both tables, the common denominators between both tables. So in our query, we're going to select customer ID. So we're basically going to be working from our customers table. So our ID is going to be based on our customers table. And from our customers table, we want to get a we want to get a customer ID and a first name. And then from our orders table, we want to get an amount. So these are coming, we have customers.customer ID. So the customer ID field is coming from our customers table. We have a first name field, and that's coming from our customers table because it's customers.firstname. And then we have an orders table, or we have the amount field. That amount field is coming from the orders table because we have orders.amount. So this is the information that's going to be eventually what's shown as a result of our SQL query in this derived table, this other table that we're creating. So we're selecting the information we want from both tables. Then we have from customers inner join orders. So customers is the name of our first table, and orders is the name of our second table. And we're doing customers inner join orders. So basically joining those tables on the instance in which customers.customer ID. So this one right here, the customer ID field on the customers table is equal to the customer field right here on the orders table. So again, we're getting certain information from both tables that's specified right here. We're doing from, and then we're joining both tables using inner join. And they're specifying the criteria by which we would get rows from both tables. So let's take a look at another example. Okay, so to explore this in greater depth and kind of for you to get a better understanding, let's look at an IB example. So it says the table has been split into two tables following the rules of normalization. The resulting two tables are shown with the primary key underlined. So we have this lorry table and we have a couple of fields, and the primary key is a truck ID. And we have a trailer table with a couple of fields. We also have a truck ID field on this trailer. And that's actually how we're going to link both the lorry and the trailer. If you go back to our example right here, we were able to get like matching rows. We were able to get matching information from both tables by linking the customer ID and the customer fields, because they basically contain the same information just in both tables. We were able to find out, and we were able to use those to find the common records between both tables and then get the correct information accordingly. So we're going to do the same thing right here. So identify the steps to create a query to find the names and telephone numbers of the drivers who drive lorries that have more than 60 cubic meters of trailer space. So basically to find the name of the driver, we would go right here, we would use this field. To find their telephone number, we would find this field. And if we want to talk about how much trailer space they have, we're going to be looking right here. So one difference here is that we need to join them to create a derived table. So we need to do all of this, but we're also going to need to have another where keyword so that we're displaying in here not only the matching records between both tables, but the matching records that are basically subject to some criteria, that match some criteria. So first off, we're going to write a query first to get all the queries to get all of the records into a table that have matching truck IDs. And we're going to get the driver and telephone number from them. So we're going to do select driver, comma, tel, because that's what we want to get from, well, that's the information that we want. And actually, we want to specify what table it's from. So we're not just going to do that. We're going to do lorry.driver, comma, lorry.tel. And if we wanted to, we could get other information like from the trailer. We could say trailer.coupled to, or whatever, but we don't need to do that for this question. from, and we want to do an inner join. So it's going to be this part right here. So from lorry, inner join, trailer. And we can find matching records between these two by matching up the truck ID from the lorry to the truck ID from the trailer table. So we're going to say on lorry. Actually, I'll put this in another line right here. So on lorry.truck ID equals trailer.truck ID. And that actually gives us our derived table. So that just gives us a basic table that will show us all the matching records. So it would basically show us the driver and telephone for all the records that have a truck ID in lorry and a truck ID in trailer. But we have some other criteria where we want only the drivers from both tables that are in both tables. So the truck IDs that are in both tables that have more than 60 cubic meters of trailer space. So we're going to say where trailer space is greater than 60. So we got right here, we specified what information we wanted. We did an inner join between the two tables, and we showed that they share a piece of information right here. So we showed how they're related right here. So the truck ID from lorry is equal to the truck ID from trailer. And once we got all of the common records between each other based on the fact they share truck ID, then we narrowed it down even further by saying that we only want to display those records for which a trailer space is greater than 60. That's an example of a join right there. So let's look at another example. We'll check our answer right here, and it is actually correct. But let's take a look at another question. So maybe this will make a bit more sense because we do have tables right here. We're not just joining fields. But identify the steps to create a query to find the names of customers whose account balance is greater than 300,000. So we want to find the names of customers. And right here, we only have a family ID in accounts, but in customers, we have a family name. So this is what's going to be in our select statement. And we're going to be joining them by, let's see. Okay. So we actually have a customer ID right here. And these customer IDs are actually right here as well. So we're going to be joining them based on their customer ID because that's how we can link records between both tables. We can look for a table that has a customer ID here and that has the same customer ID in customers. So, okay, this will be our information we want. We've got our common piece of information. And then our criteria is an account balance greater than 300,000. So we're going to find an account balance right here, and that's going to be our where statement. So we can start by doing select, and we just want to print out the names of customers. So we can select customers family name, and then we can do select customers family name from. Let me just make sure that I got that right. Yeah, okay, from, and we're going to be linking our accounts and customers table from accounts, inner join, customers, and these both share the customer ID. So we can say on accounts dot customer ID is equal to customers dot customer ID. And capitalize that, customers dot customer ID. Sorry for my terrible handwriting. And then, okay, so that gives us our derived table with all the matching records for which there's a customer ID in accounts and customers. And so then we want our criteria, and we're going to say where. And our criteria is that an account balance is greater than 300,000, and that balance is found in the accounts table. So we can say where accounts dot balance is greater than 300,000. And that's pretty much it. Let's go ahead and check our answer. And so again, interestingly, I guess this is an option where you don't have to write a SQL query. It's basically like you're explaining what you would do in writing a SQL query anyways. So I mean, I think it almost makes sense to still know SQL in order to be able to actually solve this. But anyways, we have our answer right here. And that's pretty much the same thing that we wrote. Although, okay, one interesting thing right here is it wants the family name and the account's balance. Okay, so identify, okay, that's actually weird because right here it just says find the names, but here it's asking us to output the account, like the balance as well. So that, I don't really know why that is. I think that's probably a mistake because right here it just says award 1 point for identifying the family name. So okay, I guess there's kind of a discrepancy between what's shown right here and what's shown right here. You just really need to get the family name, but whatever. And here it says SQL is not required. Again, I mean, I don't know, that's kind of stupid, but I guess this is an example of not using SQL. Now, to close out this video, as always, I would like to give you some channel updates. So I debated whether I was actually going to make an option B video for a long time, mainly because I've been lazy and it didn't really seem like there are that many people who are doing option B. But I think there are actually a fair number of people doing option B, and I feel bad for you because there's literally nothing online anywhere. So I've already started working on an option B video, and I'm going to have that out before the exam. Hopefully in the next couple of weeks it'll be out. I don't know exactly when, but it will definitely be before the exam, and probably an HL pseudocode problem, or a video covering HL pseudocode problems. Long term, I'm still hard at work on A-level videos. That's not really relevant to you guys who are watching this video, but I just thought it'd be cool for you to see what I'm up to. Anyways, that brings me to the end of this video. If you liked this video and you found it useful, please remember to give it a like and subscribe to the channel. Have a nice day and good luck.